horrible today. 1 hour before Campi Flegrei volcano erupted, as Earth rose, rumbling across land. Volcanoes reawakening after long repose must rupture the crust before magma can erupt. Rupture is preceded by repeatable variations in the rate of seismicity with ground movement, which trace the amount of applied stress that is released by local earthquakes. A rupturing sequence has been developing across 4 episodes of ground uplift at Italy's Campi Flegrei caldera. In 1950 to 1952, 1969 to 1972, 1982 to 1984 and since 2004. We predicted in 2016 that the approach to rupture would continue after an additional uplift of 30 to 40 centimeters at the location of largest movement. We have updated our analysis with new data on changes in the numbers of local earthquakes with amounts of ground movement. Here we show that subsequent events have confirmed our prediction and that the unrest has been changing the structure of Campi Flegrei's crust. The results provide new constraints for evaluating the volcano's potential to erupt or to subside without eruption. One in 10 of the world's historically active volcanoes are large calderas more than 5 kilometers across. 2. They frequently pass through several episodes of unrest over decades before they erupt. 2. The episodes belong to a single evolutionary sequence, so that the behavior of each episode depends on the cumulative effect of its predecessors. 3. 4. The non-eruptive episodes can generate mistrust among communities about warnings of eruption. 4. 5. They can also produce structural changes in the crust that render obsolete conventional forecasts of eruption that assume episodes will repeat their previous behavior. The Campi Flegrei caldera in southern Italy is a remarkable example. About 12 to 15 kilometers across, it is the largest active caldera in Europe and extends west from the outskirts of Naples to the Tyrrhenian Sea. Fig. 1. About a third is partially submerged beneath the Bay of Pozzuoli. The remaining 2/3 are home to more than 360,000 people. 6. The volcano has been restless since 1950. It last erupted in 1538 after an interval of about 3,000 years. 7. Previous intervals have been as short as decades or centuries. 7, so that a return to eruption after nearly 500 years is a realistic possibility. 4 episodes of uplift have raised the coastal town of Pozzuoli, near the center of greatest movement, by more than 4 meters. Fig. 2, and twice triggered evacuations of about 40,000 people. 8. The first 3 uplifts each occurred over 2-year intervals between 1950 and 1984 at mean rates on the order of 0.1 to 1 meter per year. 9. The 4th uplift has been continuing since 2005 at a mean rate on the order of 0.01 to 0.1 meters per year. That is 10 times longer and more slowly than its predecessors. Here we argue that the change in uplift behavior has been caused by magmatic gas accumulating about 3 kilometers below the surface and inducing slow rupture in the overlying crust. Once rupture is complete, it will offer magma and gas newly ascending from greater depth and easier access to the surface than previously available. Understanding the structural changes occurring today is thus essential for making pre-eruptive scenarios more reliable. Caldera-wide ground movement and local seismicity are key measures of Campi Flegrei's proximity to bulk failure. 4. When the deforming crust breaks across all or most of its thickness. These measures describe changes in the stress applied to the crust by subsurface pressurization. The volcano is underlain by a melt-rich zone which, with a top about 8 kilometers below the surface. 10, has intermittently fed eruptions and intrusions of magma to depths of about 3 to 4 kilometers. 11, 12, 13, 14, 15, Fig. 1. Across the center of the caldera, the top 2.0 to 2.3 kilometers of crust consists of predominantly pyroclastic volcanic deposits, both primary and reworked. These lie on top of marine silts and clays, which become thermally altered, thermometamorphosed, at depths of about 2.6 kilometers and then grade into bedrock. The volcano has an active hydrothermal system to depths of about 2.5 to 3.0 kilometers, Fig. 1. Meteoric steam and volcanic gases are persistently released from fumaroles. The best known of these are at Solfatara and Pisciarelli, which are less than 0.6 kilometers apart and about 2.3 kilometers east-northeast of Pozzuoli, a coastal town near the center of the caldera, Fig. 1. The permeability directing fluid flow broadly decreases with depth from the surface deposits to bedrock 16, 17. However, local combinations of rock composition, pressure and temperature are believed to have favored the formation of two horizons with lower permeability than the levels immediately underneath. One at depths of less than 1.5 kilometers, caused by the precipitation of Ca-rich minerals in volcanic tuffs 18, and another at depths of about 2.5 to 3.0 kilometers, where silica precipitates in clays and silts near the thermo-metamorphic horizon 19, following the classic Fournier model of hydrothermal systems 20.